Hello, this is Mr. Beck. This is part 3 in my series on working with a bitmap inside of Android. This is designed for my 8th grade programming class. In part 2, we learned to rotate the bitmap based on the condition of the left and right buttons. If it's being held down, we're rotating, and if the button is being released, we're doing nothing. By the time we finish with this video, we're going to change this middle button, and I went ahead and I just changed it from fire to thrusters. When you press the middle button, you'll be able to send the rocket off in the direction that it's pointed. Now, the longer you hold down the thrusters button, the faster it'll go. And when you release the button, it will slow down and eventually come to a stop. So that's where we're headed. Let's go ahead and get started. Up at the very top of the class, I've rearranged a couple of things. First of all, the value rotation in the initial program is an integer. And I'm changing that to a float now because we're going to need it to be more precise. So you want to change that to a float. That's going to be fine for this. Position X and position Y are kind of important. They are declared in part 2 in the update method. There's a declaration there, and they're both ints. I need you to go into the update method and delete the declaration of position X and position Y, because we need to declare them globally now at the top of our class. And we're going to make them floats instead, because again, we need these to be more precise. Okay? So at the top of the class, we're going to have float position X and float position Y. We're going to set those to 0, and you're going to erase the declaration of them inside of the update method. I've added a variable, an integer, start, and I'm setting it to 0, and you'll see how we use that in a second. And I've got a float that's called speed here that's going to hold the speed value, how fast our rocket is moving. So it's important that we have all of this set up correctly. You might want to pause and do that. Okay. Right, so let's take a look at onDraw. Now, onDraw is a method that is being called frequently. It's refreshing the screen. Therefore, it's good to use as you can use it for game ticks. That's kind of how I like to think about it. Every time there's a screen refresh, it's a game tick. And button 3 is the center button. So in the event that button 3 is pressed, we're toggling that getter-setter static integer to 1. So what we're going to say is, in the event that, that integer is toggled to 1 in the getter-setter class, we're going to increase the value of speed by 0.04. Now, it initially starts out with a value of 0. The rocket is sitting still. So after the first screen refresh, it'll be 0.04. Second screen refresh, 0.08. Third screen refresh, 0.12. And so on, as long as you hold it. It will continue to get faster. Now, otherwise, we're saying, go ahead and subtract from the value of speed. So the effect of this is, if the button pressed is 0 or it's in the up position, we're going to subtract from speed. And you can see that I've just chosen to subtract from the value of speed at a lesser rate than I'm increasing it. So it will slow down more slowly. It's up to you. I also included an if statement here, a condition. I said, if speed is greater than 0, subtract from speed. Because, if you subtract from speed no matter what, at the beginning of the game, speed is 0, right? Well, if it starts off and it's, subtracting from speed, the rocket's going to move backwards, right? And that's not what we want. So we want it to, only in the event that it's greater than 0, do we want to subtract from speed. Other than that, we won't touch it, okay? Now, this doesn't effectively set speed to 0 because this still, speed could still become a negative number. But, we could include a statement that says something like, if speed is less than 0, speed equals 0, just to make sure that speed maybe becomes 0 at some point in case, speed for some reason drops below that 0 threshold and the rocket does start going backwards, we can stop it. Something to think about. So anyway, in the onDraw function, go ahead and make sure you've got the logic that increments the speed value in the event the button is pushed and decrements it in the event the button is in the up position. Okay. So most of what we're going to do here is going to be inside of our update method. So let's take a look at that. We start with a start integer. Now, at the beginning of the game, start equals 0. And eventually we may want to build in a reset button, but for right now we only want to position our icon at the center of the screen when the program starts, right? So we're going to check to see if start equals 0. We're going to get the, we talked about this in part 2. We are going to get the dimensions of our screen, the dimensions of our bitmap, divide by 2, figure out where the center is, and set position in X and position Y to our center values. And then we're going to toggle start to 1 so that doesn't happen again. So right at the beginning of the game, we're at the center of the screen. Start becomes 1. This if statement gets called one time. That's it. Again, later on, we may call this again when we do, we may build in a little button that says reset or come up with some type of game logic or game mechanic that resets the position of the rocket. And then we can use this later. Now, in the original program, I have a block commented out, and it says, we will uncomment this in lesson 3, and that's this set of logic here. What we're doing is we're taking the rotation value of the rocket, essentially, and we're multiplying it by the speed factor, okay, to determine how far it needs to go and in what direction based on X and Y. I pulled this logic from Stack Overflow just by Googling, I needed to find some logic that would allow me to do just this, move an object in a direction based on rotation. And this works. If you want to read up on the trig here and everything, I encourage you to do so. So anyway, we determine the rotation angle, and we make a determination as to what the next X and Y coordinate should be based on the speed. So we're taking the position X and the position Y where the rocket is currently, and we are adding, a value to that based on this formula. And the upshot is, no matter which way it's rotated, in the next frame, it will move in the correct direction a specific distance. Now, just to kind of think about this a little bit further, let's say at the beginning of the game, speed is 0, which it is, right? And let's say the rotation value, it's rotated 20 degrees. Well, it's going to go through and it's going to rotate. It's going to check. It's going to do, the math. It's going to convert degrees to radians. And we're going to pull the information we need. And then it's going to multiply it by speed, which is 0, which is essentially going to set speed X to 0. And again, speed Y will also be set to 0 because we're multiplying by 0. And then when we take position X and position Y, which at the beginning of our game is the center of the screen, and we add 0, what do we get? The same position. And as we increase speed, the distance between where it is now and where it needs to be in the next frame increases. So as that distance increases per screen refresh, we get the impression of the rocket speeding up. Anyway, this is good logic to have. This is a nice little formula here, and it works. So this is a good one to reference, I think. All right. So anyway, I did one more thing. Once you've uncommented that block, down here at the very bottom of our update method, I thought about it, and if the person, you got to think about what your end user is going to do, and that can be really, really difficult. If the end user holds down the button, making it go to the right for a minute, well, eventually we're going to get a greater value for not even less than that. We're going to get a value that's greater than 360. And realistically, we want the rotation value to keep everything sane. We want to keep it within a 360 degree range. So, I went ahead and I thought, okay, well, if rotation equals 360, let's reset it. And if rotation equals negative 360, let's go ahead and reset it. That way we know that the rotation number there will always be somewhere between negative 360 and 360. So an if statement like that, keeping our rotation value inside of that 360 degree range, it makes sense. And, because rotation is a float, we may want to go ahead and cover our bases by saying, if it's greater than 360, make it 0. And this will maybe give us some strange results, but it's something to think about. And I'll say if it's less than 360, make it 0, because our rotation is a float. Therefore, there's no guarantee that it will equal 360 exactly. It may equal 360.4, right? And in that event, I'm going to say, okay, go ahead and set it back to 0. Or if it equals negative 360.265, well, go ahead and just call it 0. And that way we can kind of keep things in that range. Okay, so once you've gone through and you've put your variables up here globally, you've set your speed logic inside of onDraw, checking for that button press, and we've uncommented our directional logic here. You're ready to roll, and when you run the program, you should have those thrusters working. So that's it for part 3. Thank you for watching, and we will continue to build on this particular application as we move forward. Thank you.